Okay, here we are going to find the equation of diagonal BD. Before we find the equation of diagonal BD, let me tell you something about the square. Just remember that in a square, diagonal always bisect each other in a right angle. You can see it here. This will be equal to this and this will be equal to this here. Since diagonal bisect each other, and not only diagonal bisect, but this will bisect each other in right angle. So this fact you do not forget here. Okay, now in order to find equation of any straight line, you know how we find equation of straight line. If you want to know how to find equation of straight line, I have made a, you can watch my previous video also, okay, where you can find how to find equation of the straight line here. Okay, the first thing here, before we find equation of the straight line BD, diagonal BD here, we have to look at these properties here. Since diagonal bisect each other at a right angle, so this will give you the two different things here. First thing is that you will get the midpoint of AC, okay, coordinates of the midpoint of AC diagonal, which will be the same for the diagonal BD also, since they bisect each other. Another thing, since they bisect each other at a right angle, we can use the relation of the slopes here, because we know that if the two straight lines are perpendicular to each other, then what will happen? The slopes of both of the slopes, or the slopes of both the diagonals, will be equal to -1. Okay, I'll show you here. If the two straight lines are perpendicular to each other, then we can see here that m1 times m2 will be equal to -1. We know this fact, right? So we can find here for the diagonal, in order to find the equation of the diagonal BD, we can find the slope of the BD, and as well as we can find a point on BD, and we can find with the help of the diagonal AC. Okay, now here we find first the coordinates of the midpoint of diagonal AC, because we want to find here the midpoint of this AC, right? So how can we find this, the coordinates of the midpoint of diagonal AC? We can simply use the midpoint formula. As you know that this will be equal to x1 plus x2 divided by 2, right? And comma, it will be y1 plus y2 divided by its 2. Okay, so this is the midpoint formula here. So let's use this one. How can we use this here? So look at the AC here. AC has got the coordinates -2 comma 7 and 4 comma -3. So when we look at the x1 and x2 here, it will be here -2 plus, okay, that is 4. You can check the coordinates here, divided by 2. And if you look into the y1 here, y1 is 7 and y2 is -3, so I can put here -3 and divided by the 2. Okay, so this will be equal to, now 4 minus 2 will give you 2 by 2, okay, comma, so this will be 4 by 2. Okay, remember this is 2 by 2 here, so it will become here 2 by 2 is 1, so this is 2. Remember, this is 2. 2 by 2 is 1 comma 2. Okay, here, since we know that diagonals bisect each other, right? So the coordinates of midpoint of diagonal AC will be the same for the coordinates of the midpoint of BD also. So what is the coordinate of midpoint of BD? That is also 1 comma 2. Okay, now we find here the point on BD. So we can say that BD passes through 1 comma 2. Now in order to find the equation of BD, we need to find the slope of BD. And how can we find that? I already mentioned here that, diagonal bisect each other at right angles, which means that AC and BD are perpendicular to each other, right? So in order to find the slope of BD, we can find the slope of AC. Here, we know that the slope of AC is equal to y2 minus y1 upon x2 minus x1. Okay, here look at the AC once again. What is y2 here? It is minus 3 and minus 7 and divided by x2. X2 is here 4. Okay, that is x2 is 4. Since x1 is minus 2, I can write here plus 2. So this is equal to minus 10 divided by 6. If we simplify this, then this will get here. It is minus 5 by 3. Okay, 5 by 3. So here I can just consider the slope of AC is m1 here. Now look at here. Since I have already mentioned that diagonal AC and BD bisect each other at right angles. So here we can see AC and BD are perpendicular to each other, right? Which means I can use the slope relation here. And we know that when the lines are perpendicular, then remember the slope m1 times m2 will be equal to minus 1. Here, I consider the slope of AC is m1. Now, let me think that slope of BD is m2 here. Okay, if I consider the slope of BD as m2, then here m1 is minus 5 by 3 and times it is m2 will be equal to minus 1. So now negative, negative. If I cancel this one here, then here I will get m2 will be equal to, if you cross multiply this one, see this is 3, okay? If you cross multiply here, this will, you will get here 3 by 5. Okay, so this is the slope of BD. This is the slope of BD. Okay, now here we got a point on BD, which is 1 comma 2. You can see it here, which is 1 comma 2. And we got the slope of BD. Slope of BD is here. It is a 3 by 5. Now see, if a straight line has a slope and a point, then we can use here point and slope form in order to find the equation of straight line. Okay, now we can find the equation of the straight line BD passing through 1 comma 2 and having a slope as 3 by 5 is given by, we know that we can use this one, y minus y1 is equal to m2. Okay, because the slope of BD is m2 here, so m2 x minus x1. Okay, here now look at here, or y minus y1. Look at here, y1 is 1 comma, here point is 1 comma 2, so we can just use x1 and y1. Okay, x1 is 1 and y1 is 2 here, so we can just write here 2 is equal to, our slope is 3 by 5. Okay, and here it is x minus x1 is 1 here. Okay, now now let's cross multiply this here. It is 5y minus 5 to the 10 equals to 3x minus 3 here. Okay, so let's put x and y together. So this is minus 10, you transpose minus 3 here, it's a plus 3 is equal to 3x minus 5y. Okay, and here, or, so this will be equal to minus 7 is equal to 3x minus 5y. Okay, or we can just say here it is 3x minus 5y, and here we can write here plus 7 is equal to 0, right? So this is the equation of diagonal BD. Okay, here we found the equation of diagonal BD. Now you know how to find the equation of the diagonal, okay? Diagonal of the square. Now, hope you like this video. And if you like this video, don't forget to like this and don't forget to subscribe and press the bell icon.